Computer numerical control, CNC. Machines are closely related to the history, manufacturing technology, and computing. Here is an overview of their evolution. Early foundations, 1940s, 1950s. Predecessor, NC machines. Before CNC, there were SECI, numerically controlled, NC dots machines, which used punched tapes or cards to control machine tools. MIT Servo Mechanisms Lab, 1949-1952, the U.S. Air Force sponsored research at MIT to develop a machine that could automatically manufacture complex aircraft parts. First NC machine, 1952. John T. Parsons and Frank L. Stulin, MIT engineers created the first numerically controlled milling machine, using punched tape instructions. Transition to CNC, 1960s, 1970s. Introduction of computers. As computers became more accessible, NC machines, CNC, computer numerical control, evolved, replacing the punched tape system with a computer. Mini-computers, microprocessors, 1970s. The introduction of mini-computers, such as the PDP-8, and later microprocessors, made CNC machines more affordable and versatile. CAD, CAM integration. Computer-aided design, CAD, and computer-aided manufacturing, CAM, CNC, also began to integrate, paving the way for more complex designs. 3. Modern CNC, 1980s present. PC-based CNC, 1980s, 1990s. Personal computers replaced proprietary controllers, making CNC machines more flexible and easier to program. High-speed multi-axis machining, 2000s. Advances in servo motors, precision controls, and software paved the way for YITS. For 5-axis CNC machines, which enabled highly complex geometries. Automation Industry 4.0, 2010s present. CNC machines now integrate Internet of Things, AI-driven optimization and robotic automation, enabling smart manufacturing. Key milestones. 1952. First NC machine by MIT Parsons. First commercial NC machine by Quixar Bendix Corporation. 1970s. CNC with computer control replaces NC. 1980s. CAD-CAM software revolutionizes CNC programming. Body, high-speed multi-axis CNC becomes standard. 2020s. AI, IoT, and cloud-based CNC machining emerge. Types of CNC machines. CNC, computer numerical control machines, come in many types, each designed for specific manufacturing tasks. Here is a breakdown of the most common CNC machine types and their applications. 1. CNC milling machines. Function. Uses rotating cutting tools to remove material from a workpiece. Variants. Vertical machining centers, VMC. Spindle moves vertically. Horizontal machining centers, HMC. Spindle moves horizontally. Great for heavy, deep cuts. 5-axis CNC mills. Can move in 5 axes for complex geometries, aerospace, medical. Applications. Metal, plastic parts, molds, prototypes. 2. CNC lathes, turning centers. Function. Rotates the workpiece while a stationary cutting tool shapes it. Variants. Swiss-type lathes. High precision for small parts, e.g., watch screws. Multi-axis turning centers. Combines milling and turning, live tooling. Applications. Shafts, bolts, automotive parts. 3. CNC routers. Function. Cuts softer materials, wood, plastic, foam, at high speed. Applications. Furniture, signboards, cabinetry, CNC plasma cutters. Function. Uses a plasma torch to cut conductive metals, steel, aluminum. Applications: metal fabrication, automotive frames. 5. CNC laser cutters. Function: uses a high-power laser for precision cutting, engraving. Variants: CO2 for nonmetals, fiber for metals. Applications: sheet metal, jewelry, electronics. CNC water jet cutters. Function: uses a high-pressure water stream with abrasives for hard materials to cut. Applications: stone, glass, aerospace composites. CNC EDM, electrical discharge machining. Function: uses electrical sparks to erode material for hard metals. Variants: wire EDM, cuts with a thin wire, mold making. Our sinker EDM, uses custom electrodes to create cavities. Applications: dies turbine blades. 8. CNC grinders. Function: uses abrasive wheels for ultra-precise finishing. Applications: tool sharpening, automotive bearings. CNC press brakes. Function: bends sheet metal with programmed force. Applications: enclosures, chassis parts. Turning flow control system types.